Morning, everybody. Morning. Welcome back, or welcome to the reliability stage if you've just arrived. I'm delighted to welcome Shereya Parashar, who is talking this morning. I've got to quickly check my phone. I'm not very good at this sort of multitasking because she sent me an excellent bio. A mechanical engineer by degree and a reliability engineer by sheer luck. Like many in the field, she stumbled into reliability early in her career, and her passion in this field grew organically. Today, she can't imagine doing anything else. A true data enthusiast, Shereya firmly believes there is no better love story than data and reliability engineering. She often finds herself applying reliability principles in her personal life. Shereya has specialized in digital transformation projects with a focus on turning data overload into actionable insights that enhance asset performance. Off the clock, Shereya swaps Power BI for sippy cups with her toddler and practices bridal henna design that can take 6 hours to complete. Really looking forward to hearing from you. Thank you. Do come in and have a seat if you'd like to have a seat if you've just arrived. Thank you very much.
Thank you. I'm going to kick off with a little story. So in the last 2.5 years, I've gone on one of the most incredible journeys, which is the journey of motherhood. And I've come across many parallels between parenting and reliability engineering that I'll share with you today. So in my very first year, I found myself using root cause analysis to understand any time my little one slept more than 2 hours, so I could replicate those conditions again. I was calculating key metrics such as MTBF, mean time between feeds, and I was collecting a whole host of data on my newest and most prized asset. In my second year of parenting, I learned all about equipment criticality analysis. And this car is not any car, it's the most critical asset in my household. And like any parent or reliability engineer, I bought not just one, but 2 spares. Without this car, there's maximum disruption to our household operations. In juggling toddler toy antics, I really understood the importance of equipment criticality analysis. So whether you're looking at industrial assets or your own home assets, really understanding what's important and equally what's not important is fundamental in keeping your operations running smoothly. So today I'm going to be talking about how Woodside, who's an oil and gas company, implemented an automated and dynamic ECA program that delivered 7-figure savings, and how you can take our key learnings into your organization. So starting off with the most important question, why? Why ECA? Any reliability initiative that you do undertake must impact your business bottom line. And as reliability and asset engineers, we can influence this by a range of different ways. So by optimizing reliability, availability, utilization, maximizing production, optimizing OPEX, reducing downtime, etc., while always ensuring that we achieve our safety and manage our business risks. Now, one of the key threads that enables us to do this is actually ECA, and I'll show you how. To maximize revenue, really need to focus on the most high-impact equipment, and ECA enables us to understand those. In terms of safety and emissions, assessing risk associated with asset failure against these metrics enables us to actually prevent incidents that can harm our people and our environment. Optimizing reliability, availability, utilization, and reducing downtime. Well, ECA allows us to tailor our maintenance strategies to the most critical assets. And optimizing OPEX and reducing costs, well, by focusing on critical assets, we really do avoid unnecessary expenditure. So it is almost a no-brainer to do ECA. So what exactly is ECA? In simple terms, it is just a methodology to determine our most important equipment to the least important, which is very specific to your organization and your business. At Woodside, an oil and gas company, we use the traditional ABC asset categorization that you may have seen before. In this categorization, anything that fell into category A was equipment that had a primary function of safety. So think of a fire water pump in a hazardous area. Anything that fell into category B had a primary function production, so a production pump. And then anything that didn't quite fit into A and B fell into category C, which was non-critical. Now, this kind of traffic light system, unfortunately, meant that 80% of our equipment just fell into bucket A and B. And as the saying goes, if everything's important, then nothing really is. So this A, B, and C categorization worked well at the start, but just was not what giving us value now. So this is why we pivoted down our ECA path at Woodside. Our ECA journey was quite a complex project, but at its fundamentals, there was 5 key steps that I'll take us through in a bit more detail. The very first step, and the most important step, is the why. So really deciding and initiating the ECA project. And that's defining our objectives, gaining our stakeholder support, getting the budget and the right people on the project. It really is the heart of any of our reliability initiatives. Secondly is developing the framework. So what are the parameters that we're going to assess our equipment against and applying our scoring criteria. Step 3 is around collecting that data, analysing criticality and validating our outputs. And step 4, one of my favourite steps, is really the value extraction piece, the reason we set out on this journey. So it's using ECA to deliver business value. And then step 5, with any good process, it is keeping ECA relevant so it can deliver continuous business value. So these are 5 key steps that I'll take us through in a bit more detail. So very first step, at Woodside, we had 3 key issues or challenges, and these were our objectives from my ECA program. We really needed to have clear identification of our operation and maintenance focus areas. We needed to optimize our OPEX, and we wanted to move to a more reliability-focused maintenance activities on our asset. So these were the 3 key drivers for us. In terms of resources, we had 2 reliability engineers on this project for the duration. We had discipline engineers that were involved when we went into step 3, analysing and scoring, and we had engineering and maintenance teams involved through value extraction. And we also had our AEM specialists when it came to step 5. And in terms of scope, we used the agile approach, which was a key enabler for our project. We started off with a pilot program, only taking through 4,000 equipment through the ECA project. This allowed us to really understand how we were going to do ECA and enabled us to pivot fast when we encountered problems. We extended this to additional assets, and then once we were happy, we were able to rapidly scale our project and deliver value fast. So this is what worked for us. In step 2, developing our framework. So these are the essential inputs into our criticality analysis. At Woodside, we engaged with DuPont and we landed on a risk-based ECA approach, which looked at really understanding the consequence of failure of our equipment times by the probability. For consequence, we had 4 high-level parameter areas that we looked at, so business impact, strategic impact, maintainability, and any impact to health and safety. And within those, we had various parameters as well. So in terms of business impact, we really looked at what was the failure going to be on our production and based on our customers as well. In strategic impact, we looked at the impact to our strategic plan, so our strategic obligations and plans. In terms of maintainability, we looked at mean time to repair, so the key reliability parameters, replacement cost, redundancy factors, and health and safety was looking at the risk of failure to health, safety, and environment. And that was multiplied by our reliability value, which was mean time between failure for our equipment. Now, within each of these parameters, we had a scoring system and multiple different data sources that we used to get those parameters in the first place. So we put bands appropriate to our business. And this is just an example of what we did here. And this is how we did that scoring across our equipment. So for each of those 4 key areas for consequence, we took a weighted score in that categorization. And we did that across the board. We took the highest values, in this case the maintainability score of 7, and multiplied it by our reliability value, so keeping it nice and simple. And we did this across the board. What we ended up with was raw values on the left side there, or right side, and then we actually overlaid a distribution so that we could put our equipment from 5 different banding, from non-critical all the way up to super high critical. Now this process was very tedious. It was line by line, each equipment at a time. And that's where we encountered one of our first major challenges. There was going to be a huge effort involved putting through, at that time, 200,000 plus equipment through our ECA process. And each one of these assessments were taking 20 minutes. So we had to pivot, and we had to pivot fast. What we did realize was that a majority of our ECA parameters were coming from some data source. Not all of them, but majority were. And there was an opportunity to actually automate this. This was an interesting challenge, noting that we were doing it one by one and achieving a high, accuracy in our outcome, but moving away from that and actually relying on our data meant that we would have to take a cut in our accuracy, so a hit in our accuracy. And it was really a decision point for us to have a look at the accuracy actually impacting our final outcome. And we really decided that we're going to pivot and we're going to use our data sources to the best of our abilities. So our solution was automating ECA. And the business impact and the biggest benefit, one was that we could put most of our equipment through ECA, but it also meant that we could keep it automated and sustainable in our business. So there was a really huge driver to do this. So we embarked on our dynamic ECA journey. How did we do this? So the very first step was identifying and extracting our data. So for each parameter, we put rule sets in to determine exactly where we were sourcing that data from. We established the rule sets. Now, there was multiple data sources, as you can imagine. So just for replacement costs, looking at our SAP history, looking at BOM costs, construction types, and industry norms. So a range of data sources to help us identify replacement costs and the banding that our equipment falls under. So a lot of effort was taken to actually establish these rule sets in the first place. From there, we calculated our ECA scores. And then we validated these against our manual ECA, which was really good because we had done that manually. And then from there, we overlaid our distribution again and categorized our equipment from super high all the way to non-critical. The next piece was all around the data governance. So storing our ECA outputs and then actually keeping them live. Now the step 4, one of the best steps, my favorite step, is really extracting value from this project. And these were the things that we looked at, the different lenses. So for anything that fell into low criticality or non-critical, we took the lens of cost savings. So this was all about actually justifying the maintenance that we're doing on this equipment and making sure it is actually addressing credible failure modes at the right frequency. So the mindset was justify it in. For anything that fell into the middle category, medium critical, this was all around optimizing. So optimizing our strategies using PMO, condition-based and RCM strategies. We looked at sparing and looked at reliability improvements on any reoccurring issues. And then for the last bucket, for anything that fell into the high critical bucket, this was really about reducing failure impact. So for super high critical, we looked at optimizing spare parts, reducing mean time to failure, RCAs to determine failure causes, and overall reliability improvement plans. So these were the different lenses that we looked at this data in. We also did a couple of other cool overlays with ECA. So we looked at our corrective work, and most of the time we have more work to do than the money to do it and the time to do it. So this was a really interesting overlay to see our upcoming work and how that ECA split actually looked here. We also looked at our bad actors over the last 5 years. Often we can focus on bad actors that have an immediate impact on your business, but over 5 years, the cumulative impact was also very interesting to see overlaid with ECA, which helped us target our reliability improvement programs. Now, bringing this back to why we embarked on this journey, so Woodside had those 3 key objectives. And in terms of identifying operation and maintenance focused areas, we were able to review our upcoming maintenance work for prioritization, which meant that we could allocate maintenance hours within our maintenance hour budget. We were storing our ECA against equipment in our EAM system at that time, so that maintenance planners and resource estimators could really use this to drive work prioritization. And it's actually got embedded into other digital products within our business. And what did this mean? It meant really informed prioritization of work and improved efficiency. And then in terms of bad actors, we used our ECA for targeted reliability improvement programs as well. In terms of optimizing operations and also moving towards the reliability-focused activities on our assets, we reviewed our low critical maintenance, justifying them in based on credible failure modes. We reviewed high critical equipment that are not related to performance standards and embedded ECA into other digital tools in the organization. And as a result, we actually had 7-figure annualized savings from doing ECA. Now the last step is the review improve, and luckily Dynamic ECA enabled us to achieve this. So going through this ECA journey, there was a number of key takeaways that I'll share for anyone that might be embarking on that journey or considering to. So the very first one was the benefit of using Agile. So this was a key enabler for us. So doing ECA on a small subset of equipment and then rapidly scaling really helped us enable outcomes rapidly for our business. Number 2 is considering automated and dynamic ECA in your front-end planning. So if you're embarking on this, it's something that I would definitely recommend considering how we could automate it. Number 3 is really the balance between accuracy and the impact on your final outcome. And as we do move towards more and more data, this is something that will come up quite a bit. So do we go finding more data, or can we use the data we have to make an informed decision? And then important is around the continuity of reliability initiatives to deliver long-lasting business impact. So something that's actually sustainable that you can keep doing in your business is very important. And ECA is a journey, and it's one that's worth embarking on, and it's one that we're still on as well. So with that, to recap, the 5 fundamental steps was deciding why we were doing this project in the first place, developing our framework, analyzing and scoring our equipment against this framework, extracting the value for your business, and then continuously keeping ECA alive. So in my home front, I am on this ECA journey, on this dynamic ECA journey, because the car that I showed you is no longer the most critical asset in my household. It's now this aeroplane. So I'm learning all about dynamic ECA still. Great, thank you. Any questions? Lucky first.
I have 2 questions. The first question is that with respect to performing a criticality analysis, do you use something like decision-making tools like analytic hierarchy process or something similar? There are multiple processes. AHP is just one of the examples. Second, with respect to the analyzing of the data, do you use something like PC or principal component analysis or singular value decomposition, those kind of things?
Can you repeat the first piece again, please.
Okay, the first question is that with respect to a decision making, because eventually it's a decision making, are you using decision making tools or your software that you're using, something like analytic hierarchy process or AHP, where the different parameters that affect the decision making tree, they're arranged in a matrix form, and the critical values or the eigenvalues of the matrices are computed, and the corresponding eigenvectors, they actually give you the weightage of the different parameters, which helps in decision making. The software that you're using or any other method that you're using, are you using something similar to analytic hierarchy process? That's the first question.
That's a good question. I've not heard of this analytic hierarchy process, but what I will say is that the ECA program, it was a Python program. It was very quickly coded with our scoring criteria. So essentially the intent was to score each of our equipment against those parameters that I did share. And then that was used for our decision making. So hopefully that answers your question.
Yeah, it does, yeah.
Yeah.
And the second question was that with respect to the analyzing the data, because there's a lot of data that you're analyzing, and it is set in the framework is dynamic, because that's, I think, the key point that you want to emphasize. I mean, one of my thought is that principal component analysis is something that can be used, just like singular value decomposition, from the set of data to identify the most critical parameters. I mean, one example being what we do in a mobile phone. I mean, when we take a photograph and we send it, it squeezes. That means what it does is that takes away the unwanted data and keeps the code data. So something similar is done in your software.
So the weighting that we use for our parameters, we actually weighted them equally, but that is up to your organization. So if production impact is the most important, most crucial element, I guess you can do a different weighting on those. But for us, we actually did a simple weighting across all our parameters.
Thank you.
Hello. I have a question about who is responsible to perform the scoring. Is it an individual effort or is it a collective one? That's the first question. And the second is, looking at the criteria that you have right now, with the exception of business impact, have you thought about building into the assessment parameters about future fit, future strategy, and something like that?
Yeah, great. So in terms of scoring, we had reliability engineers actually doing that scoring because it is just a mechanical score. But in terms of actually putting the band, so a lot of our scoring actually almost fell into like a 0 to 50 when you got a raw value, and then you have to actually overlay the distribution on top of that. So that's where we actually did engage with our discipline engineers who know their equipment quite well. And with our the ECA that we did line by line, that was a really good basis that we used to actually check and confirm how we overlay our distribution and do our scoring. And the second question was, so the parameters, what I'll do, I might just bring it up. So the parameters that we did use, we did look at actually the strategic part of things as well. So it wasn't just production. We did note that our strategic plan is really, really important. Also, our impact to customer as well. So we do deliver different products, LNG, oil, and we're also moving into hydrogen. So those type of strategic parts were also part of our ECA. So it wasn't just about LNG.
So for example, for another industry, it could be a program for which the asset's on or something like that.
Yep. Which is why this is it needs to be tailored to your organization. Yep.
Hello. So you said you've got an asset base of around 200,000. So based on the output of this, what was the split between, what was the percentage split of most critical to less critical assets?
So with our distribution, we wanted to overlay it so that we had about 10%. Like it was a bell curve really. So that was the best way that we did it. So that was our split. Yep. But you can put any distribution on it.
Yeah, thanks, Shereya. Quick question. So in my role, I was not just dealing with assets in a site or even assets in a business unit, but assets in different product groups. How do you deal with the dynamic nature of markets? Because this year, iron ore may look great. Next year, aluminum may look great. And so you have a tendency to want to put the assets where the money is. Unfortunately, asset management investments don't do well with an on-again, off-again approach, responding to the dynamic nature of markets, demand, supply, pricing, profit opportunity. Thanks.
Yeah, that's a really good question. So I guess we identified that we do have different products that we sell. We also have a different strategic plan that we are moving into more of the green energy as well. So that's where it kind of fit into our customer impact and strategic plan impact. So when we looked at production impact, I guess we can actually estimate what that looks like when we do lose product based on the market sell rate. So that was quite easy to capture in our production impact. And then when it came to strategic plan, that was actually looking at it every year and updating those parameters. So what is our strategic direction? What has changed in the economic side of things, so that we could actually keep this live and dynamic. And we're still on the journey.
And a quick follow-up question. How do you deal with business unit product group leaders that say, hey, we're making all the money, give us all the resources this year? Again, creating excessive variability in terms, because assets just don't respond on a dime. They don't turn on immediately. We have to have some kind of a sustained base load of investment. So how do you deal with that aspect while maintaining the benefits of the human component? Leaders yelling, hey, we're making money, they're not. Why are you giving them anything?
That is definitely really challenging. What I did find was that ECA was a really great quantitative method that actually helped us understand all of our equipment across every asset, across different sites, across worldwide. So it was almost like a basis that we could always fall back onto. And I guess those discussions, the human side of it, this played a really big part into that. And it made those discussions a lot more robust when we talked about budgets.
So I'm developing some maintenance plans for a first-of-a-kind facility with, I mean, we've been in operation for like a year and a half. It sounds like for your equipment criticality analysis, you had like a large quantity of background data to develop your automation or to mine for criteria, really. Do you have any recommendations for someone who has like a very heavily instrumented plant, but not a lot of background information, not a lot of work order records, for instance, to develop a dynamic, automatic ECA?
Yeah, that's a really good question. And you're right, we have actually 30 years of operating data, which is what made this process more data-driven and enabled us to be data-driven. I guess the ABC categorization that we had at the start was when we actually started operating our plant, so we didn't have the data. So the ABC did work really well initially, so perhaps it's even looking at a very simple approach to ECA and even looking at the parameters that really matter and where you actually have data. So you might not have things like failure rate data, but the industry would have it. So a reader and all those, like, I guess your manufacturers would have that type of data, and then perhaps there's some parameters in here that are actually something that you can calculate right now. And you can always make the refine ECA as you go along. Yep.
My question is actually very similar to that, but I was just interested to know on your sort of automation journey, did you have any other challenges with either poor quality or missing data, and how did you overcome those?
Absolutely, always. There was definitely, to automate and actually get our rule sets took a really long time. So I like to think of it like we really had to slow down to speed up our process. So there was a lot of rule sets, a lot of documentation that we had to write. So just finding replacement costs is really difficult for every single equipment. So we had really robust rule sets that we engaged with our reliability engineers, our maintainers, the people that know that equipment. And then there was parameters that we had no data at the time. With AI, there's a lot more thinking now about what we can do. So things like redundancy factors, we can actually start using AI perhaps to help us with that. So yes, we had gaps in our data, but we did our best efforts to, I guess, get as much of it as we could. What was really key for us is that we weren't looking for accurate. We're not actually using the raw score. We didn't care if it was 56 or 51. We actually were really interested in which band it fell into. And because of that, the sensitivity meant that we could actually take a hit in accuracy because it wouldn't end up moving us between bands very much. So that's also something to consider, that you don't need the best data. It's really about what are you trying to do with it.
Thank you very much, Shereya. Thank
Thanks,
you very
everyone.
much. Just a quick round of applause. Please, can I ask you all to complete an evaluation form in your app? Shereya yesterday mentioned to me that she finds that very useful, that feedback, so thank you. You can meet with Shereya at 12:50. I believe you are going to be down in the what used to be called Speaker's Corner, that's now called something with 4 words that I can't remember, Pro Reliability Knowledge Corner. Also you're on the AI panel this afternoon, is that right? Okay, okay, perfect. So if you'd like to ask more questions, please do find her later on. If you're staying, could I ask please that you move up that way? If you're not, I will let you sprint to your next venue. Thank you.